Start over. Modeling with polynomial functions again. Like I said, if it says modeling, all that means is write an equation. Modeling means write an equation. So if we use these functions, the nice thing about it is they gave us 3 roots, which are great. All right, but that doesn't give us our scale factor. That tells us where it crosses the x-axis. So those are very important points. However, we need something to tell us how steep or shallow it is. Enter in the other point. They gave us the y-intercept, which they didn't have to give us that one. They could have given us any of them. All right, they really could give us any point they want, but that's the one they gave us. So that's the ones we'll use. So we'll start here. We're going to plug in everything we know, and we'll solve for that scale factor. So y equals a. A is going to be the scale factor, basically how steep or shallow the entire equation is. And then we'll start here. If you have an intercept at -4, it's going to be x plus 4 or minus 4? Plus 4, there we go. All right, if we have an intercept at 1, that would be x plus or minus 1. Which one? Plus. Minus, there you go. If I have an intercept at 3, that would be x minus 3. Everybody cool with that? Sweet. From here, we are going to take this point. We will plug the -6 in for y, and we'll plug the 0 in for all of the x's. And the only thing left will be a. Okay? So, y is, what's y equal again? -6 equals a times, what's the x value there? 0. So 0 plus 4. Anywhere you see an x, 0 minus 1. Oh, there's another x, 0 minus 3. Cool. Now the only letter left is an a. Okay? And when you're down to one letter, you can start solving. So here we go. -6 equals a. What is 0 plus 4? 4. What's 0 minus 1? What's 0 minus 3? Cool. All right, let's finish it up. Real fast, what is, 2 negatives make a positive, so what's 4 times 1 times 3? What's 4 times 1? 4. 12. Times 3 would be? 12. 12, good. So we'll divide both sides by 12. And that reduces down to a equals what? What does this reduce down to? 0.5 or -1/2. There you go. So we have our a value. 4 times 1 times 3 is 12. If that is a 4, should probably clean it up a little bit.
Nope.
There we go.
The answer is
so the answer for a, the scale factor, is -1/2. So now, question. Did it tell us to write this in standard form, in factored form, in vertex form, anything weird like that? No. So we're just going to write it like this. Y equals -1/2, x plus 4, x minus 1, x minus 3. Done. They didn't tell us how they want it, so we'll give it to them how we want it. Cool? And that's it. Any questions? It is kind of easy. All right, let's do the next one. So that one they gave us an actual graph. This one they just give us some points. Question, of these 4 points, which ones are x-intercepts?
the first 3.
The first 3, so all 3 of those are x-intercepts?
No. The first and the last 3.
Good. This one is not an x-intercept. That's a y-intercept. Good.
Good job, Cameron.
So here we go. Woohoo! Good job. Let's do this, ladies. Now. So y equals a. Then put all your factors. So we're going to do x minus 4 or plus 4? Plus 4. There we go. Then we're going to do x minus 2 and x minus 5. All right. So we'll plug things in. What are we going to plug in for y? A 10, good. That's the y value for our extra point. Now, they're giving us y-intercepts. It does not have to be a y-intercept. It could be any point they want to give us. Okay, we just need one more. 0 plus 4, 0 minus 2, 0 minus 5, So we'll clean it up a little bit from there. What's 0 plus 4?
4.
What's 0 minus 2?
2.
And 0 minus 5?
5.
And nice thing about that, the two negatives go away again. Okay, what do we need to divide by? $40.
Why you make positive?
Because a negative times a negative is a positive. So I just took care of my negatives right there. Because negative 2 times negative 5 is a positive 10. Times 4 is 40. And what is 10 over 40 reduced down to? Good. Any questions about that? So write your equation. Y equals 1/4 x plus 4, x minus 2, x minus 5. Done. How are we doing with this? Give me 5 to 1. 5, I got this. 4, I'm okay. 2, I'm lost. 1, yeah. Essentially, yeah. If I give you a solution, you flip the sign and turn it into a factor. Okay. All right. So prove it. Do letter D. Do letter D on your own. D on your own. Do letter D. Do letter D. And let's pause it. All right. Let's show the world. There we go. Cool. Like I said earlier, hopefully you realize that that was a y-intercept, not an x-intercept. Yes, ma'am.
How do you got 6?
How did I get 6? Basically, I just multiplied these together. I did 1 times 2 times 3 is 6. So really, if you wanted to, you could write another line that says negative 12 equals 6 times a. And then I divided both sides by 6. I just skipped it, multiplied together, and divided it. That's all I did. I just skipped that step. Cool? All right, any questions? This is literally the hardest thing we'll do today. It's not the only thing we'll do today, but that's the hardest thing we'll do for the day. Cool? The rest is that much easier. All right? Anybody still writing? I got 2. Go ahead and turn the page. When you're finished, turn the page. When you're finished, turn the page. Sweet. All right, next page. Next page. There we go. Properties of finite differences. Okay, finite differences. We're using finite differences to ask the question, what type of function? Function. We're playing the age-old board game. What type of function? The most boring board game on earth. All right. So here we go. If your first difference is the same, well, then it's a linear equation. And I'll tell you what I mean by first difference in a minute. If the second difference is the same, it's a quadratic equation that those points make. If I take my differences and I find the third difference is the same, anyone want to guess what type that is? Huh? It's not an absolute value. It's cubic. Linear has an x, quadratic has an x squared. This would be an x cubed. Now, we're not going to go this far, but a fourth difference would be, you're at the right idea, but it's called quartic. But you're on the right track. All right, we're not going to go that far, but it could be. Cool? All right, so here's what I mean by this. All right? You notice how the x's go up by the same amount. They all go up by 1, right? To do this, all your x's have to be consecutive. They can go up by 2s, they can go up by 3s, but they have to be constant in that sense. You follow me? For this to work. So here's what we're going to do. We're going to start subtracting our y's. What is 4 minus 1? What's 10 minus 4? What's 20 minus 10? What's 35 minus 20? What's 56 minus 35?
21.
There you go. What's 84 minus 56? 28. It's okay. It's 2 points shy of 30. So that is your first difference. Are they the same? No. So this is not what?
It's not an answer.
It's
Not a linear.
not linear. If all of those were, say, 3s, this would be a linear function, and we could write the equation. Okay? But they're not, so we'll keep going. I'll change colors. Let's use pink. All right, 6 minus, oh, that's not a pink, that's an eraser. Crud. 6 minus 3 is what? 10 minus 6? 15 minus 10? 21 minus 15? 28 minus 21? Okay. Are those ones the same?
Yeah. No.
Are they the same?
Oh, no.
No, they're not.
I mean,
There's a pattern to it, yes, but are they identical?
no.
No, so this is not what?
Quadratic.
Quadratic. It is not a quadratic. All right, so we got to go one more step. You can already tell me which one it is, probably. Cubic, because 4 minus 3 is? 5 minus 4 is? 6 minus... They're all 1. So this is... cubic. And you can do your fireworks. Pew! Boom, boom. Those are your fireworks, okay? Sweet! So, again, that was the hard part.
That was easy though.
I know it was easy. So here's what I want you to do. I want you to pull out a calculon later. And I'll bring one up. Oh, there's my son. Yeah, he's cute. Actually, this cow right here, his kindergarten teacher is in love with cows. There are cows all over his room. And every weekend, she has one kid take 2 of the cows home and like do whatever they want with them, have fun with them, and they come back with a little sheet of paper with a story and pictures and say, what did you do with the cows that week? I know. Well, what it does is it's so that they can, get used to talking in front of people. That's what it's for. It's for like speech type stuff. So yeah, he was playing a game with them. And they love it. The kids love it. Just wait till you have a 5-year-old. They love doing stuff like that. That's what it is.
I wish I was a kid.
You are a kid. Clear. All right, so stat. Here we go. Let's go to the stat function. We'll go to stat, edit. If you have stuff in there, highlight, like L1, highlight it and press clear. Enter. Do not press delete. Press clear. If you hit delete, the entire list, including L1, goes away.
Where'd you go?
So hit clear.
Oh, we went to stat, right?
Go stat, edit. Stat, edit. Clear them out. Don't delete them. Clear them. And put in your lists exactly how you see them. So your X values are 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter, 7, enter. Then go over to L2. They were 1, enter, 4, enter, 10, enter, 20, enter. I think the next one's 35, then 56. Oh, it was 21? No, it wasn't. No, it's 20, it's 35, 56, and 84.
Oh, hold up.
We're not putting in the differences, we're putting the actual points in. Cool?
Then,
All right, wait for everybody to get them in, give another 10 seconds.
I just said to do this, I just grabbed my calculator.
Huh?
I just said to do it, I just grabbed it.
Oh, that's fine. All right, so hit stat. Go over to calculate, C-A-L-C. And which one of these do you think we're going to choose for this one?
The 6.
The 6, because we realize it's cubic.
Okay.
So you can scroll down to the 6, or you can hit 6. Enter. Now, if some of yours will just say cube reg right here, and you just hit enter and you're done. Some of you will look like this. You just have a slightly different operating system. So what? Just keep hitting enter until you get something that looks like that. Cool? And so your A value is 0.16, or 0.17 actually. Your B value is 0.5. Your C value is 1/3. And your D value is 0. All right, it's this x cubed, this x squared, this x plus that. Cool? So go back. Here we go. Dim mismatch? That means you have more in one list than the other. You omitted a point. So y equals 1.7x cubed. Then I think it's plus 1.5 x squared. Is that what it was? No, it's not. It's 0.5.
Yeah.
0.5. Yay! Good job. Plus 1/3. Oh, that's an x squared. Plus 1/3 x. And if you want to, you can write plus 0. Do you have to write plus 0? No, so I'm not gonna. And that is your answer. Cool. I told you this was easier than the last one we did. It really is, but not by much.
Where do you get the decimals and stuff?
Right here. ax cubed, bx squared, cx plus d. If it was a squared, like a quadratic, it would be ax squared, bx plus c, that sort of thing. Cool?
Why you put 1.74?
Because 1.66 rounds up to a 1.7.
But it's 0.1.
Oh, well, you can put a 0. You don't have to put a 0 in front of it. You could. Oh, I wrote it wrong. You're absolutely right. I see what you did now. 0.17. You're absolutely right. It's 0.17. Thank you.
Sorry.
What's up, Michael? Cool.
That was yours.
Awesome. All right, any questions on that?
All right, Mike.
Do you think you could do it on your own?
No?
Yes.
Yeah. Yeah. Do letter C. Do letter C on your own. All right. Start off. Take one and subtract the other. What is right here? What is -2 minus -4?
6.
Nope.
6. -6.
-2.
-2 minus -4. -2 minus a negative is a positive. When you're subtracting a negative, that's the only hard part is remember, oh yeah, I'm subtracting a negative, so I'm going more positive. Okay? So try this again. -4 minus -2 would be what? -2, good. Finish the rest of it on your own. Oh my gosh. Oh no. Well, already you can tell, is that linear?
Yeah.
No.
No, because are those the same?
Don't.
No. All right, so finish it up. And I'm going to do that too. Presentation hold. Pause. I know Cameron got it wrong. No, I never said you were stupid. Never said you were stupid. Terry. All right, so here's one thing. Did you notice I didn't even do this last one over here?
Yes.
Honestly, we have enough. All I would do is find another -6. I have enough to establish the pattern. Does that make sense? So I don't necessarily have to do it. All right? So you would stick it in your equation. You stick it into your equation editor, or your stat function, I'm sorry. And which regression would you pick? Cubic. Excellent. And so let's block that out real quick. Remote desktop. Come on, where's the mouse? There it is. Stat, edit. I'll need to change those. -4, -4, and -2, and -4, and -16, and -44, and -94, and negative what, 172? Yeah, 172. Enter, stat, calculate, cubic. Enter, 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 enter. There we go. And those will be your coefficients. So you got a -x to the third, a positive 4x squared, minus 3x, minus 4. And those would be your coefficients. Cool? So let's go back and do that. -1, 4, 3, -1. I don't know, whatever. Y equals -x cubed. I think it's plus 4x squared. Is that what it was? Then what was the third one? What was the C value? -3. And the last one was what? -4? Cool. Come on. That's your equation. Cool? Thank you for playing. All right. Any questions on this at all? Anything you want to go over? I know this is easy. I got one more I want to do with you, and we will stop. All right. Turn the page.
No.
No. Use regressions to build functions to make and request. Wow. Then make the requested prediction. Yeah, I can't read. All right. Build a function and make the requested prediction. Okay. So the table shows the U.S. biomass energy consumption in trillions of British thermal units, BTUs, in the year T, where T equals 1 corresponds to 2001. So first thing I'm going to do is I'm going to go over here and make sure I know that 1 is 2001, 2002, so on and so forth. I'm not going to write them all out, but that way I don't forget that. Okay? So write a polynomial model. Are they telling us what type of model to make?
No, polynomial.
Polynomial, but are they saying like cubic, linear, quadratic, anything along those lines? So we're going to put this in our calculator and make the best one we can. Does that make sense? So here you go. Whip out your calculator. There we go. Stat. Nope, not calculate, edit. And this goes all the way down to 12. 8, 9, 10, 11, 12. All right. And then we got to put in all the numbers there. So here we go. 26, 22. 26, 22. Enter. 2701. 2701. Enter. 2807. 2807. Enter. 3010. 3010. Enter. 3117. Enter. 3267. 3267. 3493. Wow, it's not putting the whole thing in again, is it?
No.
317. So that's 3117. I really hate this thing sometimes. 3267. 3267. Enter. 3493. We're making these videos and all that sort of stuff. These, on the one hand, these have got to be the most boring things on the face of the planet. And on the other things, it's got to be absolutely hilarious to watch me act like a fool. You agreed to that way too quickly. You just failed the class. I'm kidding. 42, 86. Oh, I don't have that much power. Are you kidding me? 11 is 44, 21, 4, 4, 2, 1. Yes. And 4, 3, 1, 6, 4, 3, 1, 6. Enter. Sweet. All right, so we got them all in there. We got them all in there. So here's what we're going to do. We're actually going to run all three of the diagnostics and see which one's best. So what you have to do is go to Mode and scroll down to Stat Diagnostics and make sure they are on. Okay? So on Stat Diagnostics, turn them on if they're not already. They probably are because we've been doing this all day, but they might not be. All right, and what we're going to be looking at is the R value. Okay, so the R value, if the R value will either be 0, that means nothing. It will be 1, that's perfect, but in the positive side. Or it'll be -1, which is also perfect, just on the negative side. Okay? So that's how this works. If your R value is 0, that means your line has nothing to do with the data points at all. If they are 1 or -1, that means the dots match your line perfectly. Okay? It just has a positive or negative type of correlation. So here's what we do. Go to Stat, Calculate, scroll down to Linear Reg, and hit Enter. And yeah, you get a bunch of big decimals. And you get a 0.98, so is this one pretty good? Yeah, that's almost 1. So 0.985, your linear is really good. All right, but let's see if there's one that's better. I'm actually kind of upset with this example because most of them are really close, but whatever. So the quadratic regression give us a 0.97. Is that better or worse? Worse. Okay, so we'll stick with the linear. We'll come back to it if it's right. Let's go down to the cubic. Cubic. Enter.
It's the same one. I think.
It's point. Oh, come off it. 0.988. Oh, the last one was 0.985. So this one's better by 3/1000ths of a point. Honestly, if they're that close, I don't care which one you use. But that's what it's got. Cool? So we're going to use these points. Negative 2.5, 51.9, negative 118.1, and 2732.14. All right? Cool. Huh? We did. It was 0.97. It was just slightly worse. Honestly, you could use any of these and it would model okay. This is 0.97. The quartic? Oh, we're not doing the quartics. Yeah, don't even worry about that. But you're right. That would probably, if that would be better, you're right. So that's y equals negative 2.5 x to the third plus 51.9 x squared minus 118.1 x plus 2732.1. That would be an equation that fits that data for the most part. You follow me? Good. All right. The only thing to take this one step further is this last part. It says use the model to estimate the total U.S. biomass in 2013. So we want to estimate the year 2013. Okay. So what are we going to plug in for x? We're going to plug 2013 in for x? Well, we started at 1. Is this the year 12? And we're going to go all the way to 2013? You're going to plug in 13. Good. All right. So like that, you just got to watch your trickiness. So remember 1 is 2001. 2 is 2002. So plug in a 13. Somebody please take a calculator. Do negative 2.5 times 13 cubed plus 51.9 times 13 squared minus 118.1 times 13 plus 2732.1. Just plug in 13 and find f of 13. And if we get two people getting the same number, we'll say it's right. It's 4472. Actually, I think it is like 44 something. Might be 4475. It's all of this, but plug in a 13. Oh, I think it's 4475 or something like that.
Yeah, I got 4475.
Okay.
0.4.
75.4.
Yes.
We're going with that. Cool. And that's it.